The airplane was in the process of landing when it suddenly encountered a serious malfunction. The GA controller of the engine got completely stuck, making it impossible to slow down. The situation was no different from a heavy truck losing its brakes while barreling downhill with massive inertia, heading straight toward the runway. And what's even more shocking is the cause behind this seemingly impossible incident. Hello everyone. In this video, I'll tell you the story of one of the most serious aviation accidents. The incident involving Cathay Pacific Flight number 780. After 1.5 hours of flight, Flight CX-780 entered the Hong Kong air traffic control zone. Although the visibility at Cheklapkok Airport was fairly good, the runway where the aircraft was preparing to land carried the risk of wind shear, highly dangerous phenomenon during approach. Even so, the flight crew strictly followed standard procedures, completed all approach preparations, and began to gradually reduce the aircraft's altitude. Everything in the cockpit seemed normal, except for the EPIR reading, the input-output pressure ratio of the engine, which was fluctuating abnormally. However, as the plane descended to an altitude of 80,000 feet, equivalent to 9,144 meters, the two pilots suddenly heard a small explosion. Right after that, they smelled ozone and a burning odor spreading throughout the cockpit. Next, the ECM screen displayed two consecutive warnings, one indicating a failure in engine control system number 1, and the other a flameout in engine number 2. Interestingly, the fan blade structure inside the engine had a design quite similar to that of. Therefore, aircraft engines are also vulnerable to flameout when airflow separates from the aerodynamic surface. When the compressor stalls, the combustion chamber won't receive enough compressed air to sustain combustion, causing the engine to lose thrust, vibrate abnormally, and may even lead to a dangerous case of engine choking mid-flight. Recognizing the imminent threat, the flight crew immediately implemented emergency procedures. They set engine number 2 foot to GA standby mode and simultaneously increased engine number 1 to maximum continuous power to compensate for the lost thrust. However, shortly afterward, the ECM displayed 2 more warnings, and at the same time, the N1 rotation speed of engine number 1 dropped sharply from 57% down to just about 37%. This clearly indicated that both engines were experiencing serious malfunctions. With no other option, the crew immediately declared an emergency, preparing for the worst-case scenario. The first emergency signal sent out by the crew was Pan-Pan, a warning with lower severity. The co-pilot calmly made contact. "Hello, Hong Kong. This is Cathay 780. Our engine number 2 is currently in GA standby mode. Other than that, everything is still normal. Therefore, we request heightened response level. Thank you." Shortly after, air traffic control responded. Cathay 780. "We acknowledge receipt of your Pan-Pan report." After sending the signal, the flight crew immediately initiated the approach procedure and prepared to fly again using a single engine. The captain, who was in charge of primary control, took full command of the aircraft. However, the challenges ahead were far from over. As the plane descended to an altitude of 8,000 feet, approximately 2,448 meters, the ECM screen once again issued a new warning. As soon as the two pilots read the warning, they both gasped in shock. Engine number 1 had also flamed out. Following proper emergency protocol, they set engine number 1 to GA standby. Captain McCombs quickly reached for the control lever. He tried to adjust the thrust to test both engines, but the worst had happened. There was no response at all from the system. Both engines no longer responded to GA control commands. The aircraft was now gliding midair without any thrust. At its current altitude and speed, the Airbus A330 could only glide for about 38 nautical miles, or roughly 70 kilometers. What seemed like just a few minutes from landing now became a fragile and uncertain destination for all 322 people on board. In the face of this dire situation, the flight crew was forced to escalate the emergency level from Pan-Pan to Mayday. The co-pilot quickly issued a Mayday distress signal. "Mayday, Mayday, Mayday. This is Cathay 780. Both engines have flamed out. We are currently at 8,000 feet and request permission to descend. The controller immediately replied, Cathay 780, you are cleared to descend to 3,000 feet. So what caused this disaster? The answer was shocking. The culprit was water-absorbing plastic beads inside the fuel tank. At first, they only caused slight interference with the operation of variable stator vanes, components that regulate airflow into the engine. However, after a long flight, the plastic beads began to directly affect the main fuel control valve inside the engine. They accumulated inside the valve, which is built similarly to a car engine cylinder, causing the fuel control piston to slow down or even seize completely. That is why, when Captain tried to push the thrust lever, the engine gave absolutely no response. At 13:32, Captain McCombs disconnected the autopilot, turned off the flight director, and began to slightly raise the altitude to gain more time and maneuvering space. This climb not only helped the aircraft slow down to green dot speed, an ideal speed for optimal lift-to-drag ratio in a light configuration, but was also a final effort to control the flight path by gliding. However, if both engines continued to provide zero thrust, they would not be able to accurately steer the aircraft back to the runway. In that case, the worst-case scenario would occur, a forced landing at sea. And that, under wavy sea conditions, would be extremely dangerous, with little chance of survival. During the deceleration, in preparation for landing, the co-pilot proactively activated the standby power unit to ensure backup electrical and pneumatic supply for essential systems. At the same time, the engine start switch was set to the ignition position, producing continuous sparks inside the combustion chamber to minimize the risk of both engines shutting down completely. With a mindset of as long as there's hope, Captain McCombs once again tried to move the thrust lever of engine number 1, even though it had previously shown no response. He patiently tried multiple times with small adjustments, and then a miracle happened. Engine number 1 suddenly came back to life. The rotation speed, an important indicator of engine power, gradually increased to 10,860 revolutions per minute, corresponding to about 74% thrust. This was clearly a very encouraging sign in such a dire situation. Although engine number 2 remained in GA standby mode, the thrust from engine number 1 alone was enough for the flight crew to safely land the aircraft. After resolving the issue with engine number 1, the co-pilot proposed restarting engine number 2. According to the checklist, they manually deployed the ram air turbine, activated compressed air from the APU, turned off, and then restarted the main switch of engine number 2. However, this attempt did not produce the expected result. Engine number 2 still could not exit GA standby mode. Although the restart procedure wasn't fully appropriate for the specific situation, in this highly stressful moment, the flight crew maintained exceptional calm. They weren't locked into rigid procedures, but flexibly adapted to the situation, demonstrating professionalism and impressive crisis handling skills. At 13:38, the aircraft was 9 nautical miles south of the airport, or about 16 kilometers. Configuring for landing, the aircraft needed to continue slowing down and descending to prepare for final approach. The captain gradually pulled the thrust lever back to idle, but then a heart-stopping moment occurred. The engine didn't respond. Thrust remained unchanged, without any reduction. Having just escaped the threat of an emergency sea landing, the crew now faced a new challenge: a jammed throttle. The aircraft at this point was no different from a heavy truck hurtling downhill with failed brakes. The engine that had just recovered now became a hazard, as the aircraft was only 8 nautical miles, about 14 kilometers, from the runway, still descending rapidly from over 5,000 feet, approximately 1,524 meters, 24 meters at a speed of up to 234 knots, or 443 kilometers per hour, much faster than the standard approach speed, in a final attempt to decelerate. The flight crew immediately deployed the spoilers and lowered the landing gear to create more drag. However, the drag generated was still not enough. The aircraft continued to accelerate as it dove downward to extend the flight path in order to lose speed. After passing the runway centerline, the captain maneuvered the plane around to realign with the landing direction. A risky but tactical move. made in a life-or-death situation. However, at that moment, the aircraft was still flying at 100 knots, about 180 kilometers per hour, over the normal landing limit, when it was still more than 900 feet, about 274 meters above the ground. Although the plane was still overspeeding, the captain followed protocol and retracted the spoilers to enter the final landing phase. Immediately, the ground proximity warning system blared a piercing alarm throughout the cockpit, creating immense psychological pressure. If at that moment, the crew had chosen to go around with severely limited thrust, the aircraft might not be able to clear obstacles ahead, and no one could be sure how much longer the engine could keep running, with no other options left. The captain gritted his teeth and decided to proceed with the landing. When they were about 1 nautical mile, 1.8 kilometers, from the runway threshold, the co-pilot deployed the flaps to configuration 2. However, at that speed, the aircraft exceeded the technical limits for that setting, and the flaps could only partially deploy. Nevertheless, it was the only method left to generate additional drag while the aircraft was still airborne. Amid constant warning sounds and peak pressure, the captain focused all his concentration on controlling the massive aircraft, which was still flying at 180 kilometers per hour above standard landing speed. The aircraft touched down about 680 meters from the runway threshold due to excessive speed. As soon as the right landing gear touched the ground, the aircraft bounced, and under the combined impact of the landing force and a crosswind from the right, the fuselage tilted left. To prevent the situation from escalating, the captain immediately pushed the control stick forward, but this caused the nose of the aircraft to pitch down too quickly, resulting in the left engine striking the runway directly, an extremely dangerous situation. However, thanks to quick thinking and excellent technique, the captain managed to maintain direction and balance of the aircraft on the runway. The lift dome panels, known as spoilers, automatically activated, instantly eliminating all remaining lift. The captain then engaged the reverse thrust system and applied full brakes. Unfortunately, only the left engine was able to engage reverse thrust. The aircraft continued speeding down the runway at high speed, forcing the captain to grip the control stick tightly and use all his leg strength to counteract the directional deviation caused by reverse thrust coming from only one side. After skidding for 2,630 meters down the runway, Cathay Pacific flight came to a stop just 300 meters from the end of the runway. The captain immediately shut down both engines, while the co-pilot quickly assessed the situation and prepared for possible passenger evacuation in case of any signs of danger after landing. Although the landing was successful, the threat wasn't over. Due to asymmetric engine thrust and the need to use maximum braking force, the brake pad temperature soared to a terrifying 995 degrees Celsius. Airport firefighters reported that the tires and braking system had caught fire, an extremely dangerous situation just as the aircraft stopped. Without hesitation, the captain immediately ordered an emergency evacuation. However, some passengers still tried to take their carry-on luggage, causing the entire process to take 2 minutes and 15 seconds to complete. Among the 322 people on board, 62 passengers suffered minor injuries during the evacuation. One person broke their ankle and had to be taken to the hospital for surgery. After 3 years of extensive investigation, the Civil Aviation Department of the Hong Kong Special Administrative Region officially released its report, Investigation into this serious incident. During the inspection of the engine's main fuel control valve, the investigation team found that water-absorbing plastic beads had accumulated inside. After a series of tests and thorough research, they concluded that the lack of oversight by an oil company in Indonesia, along with the local aviation authority, led to saltwater contamination of the fuel at Surabaya Airport. The saltwater damaged the filters on the fuel truck, allowing the water-absorbing plastic beads to be pumped directly into the aircraft. These tiny, seemingly harmless particles accumulated during long flights and caused serious consequences. They jammed the piston inside the main fuel control valve of engine number 1, making it unresponsive. At the same time, the variable stator vanes of engine number 2 also became completely jammed, resulting in total loss of thrust control in both engines. In response to this serious failure, after the report was released, the fuel filters on refueling trucks were redesigned to ensure water-absorbing beads could not enter the aircraft's fuel tanks. Airbus also promptly added additional inspection procedures to the pilot's flight manual to help detect signs of fuel contamination earlier, preventing similar incidents from the very beginning. Although the emergency evacuation process wasn't entirely smooth, there's no denying that every decision and every action by the flight crew played a role in defusing a disaster with extraordinary calm and a strong sense of responsibility. They successfully controlled an aircraft that couldn't decelerate to land safely. The two pilots, Captain Malcolm Waters and First Officer David Hay, saved the entire flight with an outstanding performance and nerves of steel under pressure. They were honored by the International Federation of Airline Pilots Associations, IFALPA, with the Polaris Award. In July 2014, one of the most prestigious awards in civil aviation. This award not only recognizes exceptional flying skills, but also stands as the highest tribute to courage, dedication, and extraordinary composure in the face of life-threatening danger.